An interstellar object is one whose origin lies outside the solar system. It didn't form here, and sometimes it made a very long journey to reach our star system. Some estimates say that there could be thousands of interstellar objects in the solar system at any given time. However, most of these are in the very distant regions, so we just can't see them. It's not known exactly how any one object might leave its original system and reach ours. They could be thrown out of their systems by giant collisions that smash protoplanets apart, or by the gravitational tides of gas giant planets. You know, like Jupiter, which has certainly thrown its fair share of objects out of our solar system. Astronomers estimate that an interstellar object passes through the inner solar system about once a year, but they're very hard to spot. It's only more recently that telescopes have become powerful enough to see them. To date, there are 3 known objects that came from outside the solar system and swung by for a visit. And today, for the final video of Solar System Spotlight, I will be taking a look at these visitors. 1I/Oumuamua is the first known interstellar object to visit the solar system. It passed close to the sun as it traveled through the inner solar system in the autumn of 2017. Prior to its discovery, astronomers had theorized about what an interstellar object might be like, and Oumuamua defied all of these expectations. Oumuamua was discovered on October 19, 2017, by the University of Hawaii's Pan-STARRS-1 telescope, which is funded by NASA's Near-Earth Object Observations program. This program finds and tracks asteroids and comets in Earth's neighborhood. The object was originally classified as a comet. However, it showed no cometary activity, in other words, no tails, when it zipped past the sun on September 9, 2017. This caused it to be briefly reclassified to an asteroid. But then there was another complication. Observations showed that Oumuamua was accelerating slightly, a behavior more typical of comets, but no outgassing like what happens with comets was observed. There are 2 leading explanations on what Oumuamua might be that attempt to explain its acceleration. First, it might be a chunk of nitrogen ice. The New Horizons mission found areas on Pluto that were basically just frozen nitrogen lakes. If Oumuamua is a fragment of nitrogen ice that was blasted off of a Pluto-like body, then the outgassing of nitrogen could explain its acceleration. Alternatively, cosmic rays could have interacted with ice on Oumuamua's surface. This could have liberated hydrogen from water molecules and created a supply of hydrogen gas. When Oumuamua approached the sun, it heated up, allowing the hydrogen to escape and give it the push that was observed. You may have also heard the hypothesis that Oumuamua is an alien spaceship, but there is no evidence of this whatsoever. The object is officially named 1I/2017 UI by the International Astronomical Union. It was dubbed Oumuamua by the Pan-STARRS team, which is a Hawaiian word meaning a messenger from afar arriving first. Oumuamua appears to be a rocky object with a reddish hue. It's probably pretty dense, possibly containing metals, and its color might be due to the effects of irradiation from cosmic rays. Initially, Oumuamua was estimated to be about 10 times as long as it is wide, which is an absolutely ridiculous aspect ratio. That would make it completely unlike any asteroid or comet observed in the solar system. However, astronomers later revised the estimate of its size. It's very small, around 377 feet long, 364 feet wide, and 62 feet thick. Still a weird shape, but more like a pancake as opposed to some weird cigar. Oumuamua's original star system is unknown, and we'll probably never know where it came from. Preliminary orbital calculations suggested that it came from the approximate direction of the bright star Vega in the constellation Lyra. However, its journey would have taken so long that when it came from there, Vega wouldn't have been in that position yet. In 2018, astronomers traced back the path along which it first approached the sun. They found that it passed near 4 stars, coming closest to the red dwarf star HIP 3757 about 1 million years ago. But it was probably traveling long before that, as observations suggest it could have wandered the Milky Way for hundreds of millions of years before just chancing upon our star system. Oumuamua's path is hyperbolic, which basically means it's moving so fast that the sun can't capture it into a closed orbit. Currently, it's far beyond the orbit of Neptune and passing through the Kuiper Belt. We can no longer see it with telescopes. When it leaves the solar system, it won't be coming back, and it will be heading towards the constellation of Pegasus. 2I/Borisov is the first confirmed interstellar comet. It may be the most pristine comet ever found, never passing by another star before reaching ours. Its discovery gave astronomers the first opportunity to study how a comet formed elsewhere compares to those of our solar system. Borisov was discovered by Crimean amateur astronomer Gennady Borisov, I apologize if I've pronounced that incorrectly, on August 30th, 2019. After a week of observations, scientists determined its path and confirmed it came from outside the solar system. The Hubble Space Telescope captured images that showed a lot of dust around its bright nucleus. The nucleus itself, however, was too small to be seen. In March of 2020, scientists using Hubble noticed a change in the comet's appearance. Instead of a single bright inner core, images indicated that a fragment had broken off from the nucleus. But this was later shown to have probably been just a very large outburst rather than an actual fragmentation, as the piece that broke off was a very small part of the nucleus. Borisov, especially when compared to Oumuamua, was extremely active and behaved far more like a typical comet. It's estimated to be about 3,200 feet across. Observations by NASA revealed that the heart of the comet is a loose collection of ice and dust particles. Borisov's chemical composition is a point of interest. Observations showed chemical components that we would expect from a comet, but in amounts different from what we're familiar with. This implies that Borisov formed under different conditions, which isn't surprising considering it's not from here. Borisov formed in a different star system, and it could either be older or younger than the solar system. Many comets that originally formed here were eventually ejected, so it's possible that Borisov experienced something similar. The dust in Borisov's coma consisted of compact pebbles, whereas the dust from comets in our solar system typically consists of irregular, fluffy clumps that range widely in size. This difference suggests that Borisov's pebbles formed during cosmic impacts close to its home star. These impacts mashed its matter together in dense chunks. It was then thrown out of its home system and traveled for an unknowable amount of time before reaching ours. Borisov is rapidly moving away from the sun, and it will eventually return to interstellar space and never come back. 3I Atlas is the third and most recently known interstellar object to be discovered. It's categorized as such because of the hyperbolic path of its orbit. When this path is traced back, it clearly originates from outside the solar system. As it was discovered very recently, it's still being observed and studied. The NASA-funded Asteroid Terrestrial Impact Last Alert System Survey Telescope in Rio Hurtado, Chile, first reported observations of the object to the Minor Planet Center on July 2nd, 2025. Since that first report, observations that were made earlier have been gathered from archives of 3 different Atlas telescopes around the world, as well as Caltech's Zwicky Transient Facility at the Palomar Observatory. These observations extend back to June 14th. When it was discovered, the object was about 410 million miles from the Sun within the orbit of Jupiter. 3I Atlas's size and physical properties are still under investigation. An image from the Hubble Space Telescope revealed a teardrop-shaped cocoon of dust coming off of the object's solid icy nucleus. The upper limit on its diameter is 3.5 miles, but it could be as small as just 1,000 feet across. Observations have shown activity from 3I/Atlas that are similar to that of a comet. We don't know where 3I Atlas came from or how it was ejected into interstellar space. For millions or even billions of years, it drifted until it arrived at the solar system. It approached from the general direction of the constellation Sagittarius, which is where the central region of the Milky Way galaxy is located. The closest the object will come to Earth is about 1.8 astronomical units. It will reach its closest point to the Sun around October 30th, 2025, at a distance of close to 1.4 AU within the orbit of Mars. It should remain visible to ground telescopes through September of 2025, but beyond that point, it will be too close to the Sun to observe. By early December of 2025, it should emerge on the other side of the Sun, allowing for more observations. The discoveries of interstellar objects in the solar system give astronomers a chance to learn about other star systems and how they formed. They can help us determine if the solar system is unique, or if it's very similar to other star systems and therefore pretty average. With improving technology, we're just going to keep finding more and more visitors from outside our star system. We'll be able to observe them more frequently and in better detail before they move on. As I mentioned before, this video is the final one in my solar system spotlight series. I really am very sad to see it go, but I think it's fitting to end it off with a video about things that are just passing through. Obviously, in this series, I didn't talk about absolutely everything in the solar system. That would be ridiculous, and I think it would never end if I did that. I'm not going to stop making videos about space because it's still something that I'm very passionate about. The topics will just change, and honestly, I kind of want to do more stuff like my video on Shoemaker Levy 9, like sort of mini documentaries, I guess. Thank you very, very much for watching. I hope you enjoyed this video, and if you haven't seen anything else in Solar System Spotlight, then please go check it out. I am very proud of how this series turned out. I hope you have a lovely day, and I will see you next time.